Today I'd like to introduce quadratic equations. But before we talk about quadratic equations, I want to rewind a little bit and talk about linear equations. But before we talk about linear equations, I'd like to take one more step back and talk about polynomial equations. A polynomial equation is just an equation where both sides of the equation are polynomials. For example, 3x minus 1 equals 0. The left-hand side of this, 3x minus 1, is a polynomial, and its degree is 1. Remember, the degree is the largest exponent. Another example would be 2x squared plus 5x plus 1 equals 0. Once again, the left-hand side of this is a polynomial, and the degree of this is 2 because the largest exponent is 2. Another example would be x cubed minus 5x plus 7 equals 0, and the degree of the polynomial on the left here is 3. And let's see one other. X to the fourth plus x cubed plus 1 equals 0. The degree of the polynomial here is 4. I wanted to start with polynomial equations because this gives you a nice bird's eye view of one of the objectives in algebra, and that is to learn how to solve equations of greater and greater complexity. Now, when you're looking at polynomial equations, the degree of the polynomial tells you a lot about the equation. It tells you how many answers there's going to be, and also it lets you know which techniques you need to use to solve that equation. And you start with polynomial equations of degree 1, and we call those linear equations. We call them linear equations because if you take a graphical look at what's going on, the graphs are lines. When the degree is 2, we call that a quadratic equation. And quadratic equations introduce you to a lot of other techniques that you'll use throughout algebra. Now, once you go beyond quadratic equations, you'll have things like cubic equations and quartic equations. The techniques for solving quadratic and cubic and quartic equations are very similar to each other, and so you'll spend most of your time working with linear and quadratic equations. With this, let's now take the next step and do a quick recap of linear equations. I'll write down a few examples. There's 2x equals 7. How about 5y plus 1 equals 2y minus 8? And 3z minus 4 equals 3.2. One thing that all three of these equations have in common is that both sides of the equations are polynomials. And it's also worth pointing out that in each of these three equations, there's only one variable. And also in these three equations, the degree of the polynomials is 1. And these are some of the things that you look at to determine how complex an equation is and what techniques you need to use to solve it. The more variables there are, your approach is going to change, and also as the degree changes, your approach is going to change. But in this case, all three of these are linear equations, and in fact, you will solve all of them the exact same way. Let's see how. With the first one, 2x equals 7, the goal is to just get x on a side by itself, so we're going to isolate x, and to do that we're going to divide both sides by 2. Remember, whatever you do to one side of an equation, you have to do the same thing to the other, otherwise they're no longer equal. So that gives us x equals 7/2. So that's how you would solve the first one. Now let's look at the second equation. Once again, the goal is the same, get y on a side by itself. So we will subtract 2y from both sides. Remember, if you do something to one side, do the same thing to the other. That gives us 3y plus 1 equals -8. Next we'll subtract 1 from both sides, and that will give us 3y equals -9. Divide both sides by 3 and you get y equals -3. So like before, like with the first example, we just did certain arithmetic operations to both sides until eventually we got to the answer. And let's look at the third example. We want to get z by itself, so we'll add 4 to both sides. That gives us 3z equals 7.2. Divide both sides by 3 and you get z equals 2.4. So just like with the first two examples, we did certain operations to both sides to simplify things and get us eventually to where z, or the variable, is on a side by itself equals the answer. And when you're solving linear equations, you use the same approach to all of them. You simply just solve for the variable, as people say. But that's another way of saying just keep changing both sides in the same way until you get the variable by itself. Next, let's move up to quadratic equations. And we'll look at several examples. We'll look at x squared equals 9, 2y squared minus 3y equals 0, z squared plus 4z plus 3 equals 0, and x squared minus 2x minus 5 equals 0. Now, what do these equations have in common? Both sides of the equations are polynomials. Well, in this case, really, the left-hand side is a polynomial, the right-hand side is just a number, but if you want to be technical, a number is a very, very simple case of a polynomial. Also, there's only one variable in each equation, and the degree of the polynomial in each equation is 2. Both sides being polynomials is why this is a polynomial equation. There's only one variable, and then because the degree is 2, the largest exponent is 2, that lets us know this is a quadratic equation. And that's going to be the signal that you're going to have to use different techniques to solve these equations. Now, I'd like to illustrate how you'll solve these equations. Don't worry, there will be lessons that go into detail and describe how you do this. I just want you to kind of see how, with quadratic equations, things really change. Instead of there being just one way to solve the equation, there's now several different ways you can solve these equations. And each way introduces you to an important topic in algebra. For example, let's look at the first equation. So once again, don't worry when I do things that are new to you. I just want you to see how quadratic equations use different techniques. Here, like with linear equations, you want to kind of get x on a side by itself. Here we have x squared on one side, all the numbers on the other. You will learn how you can use radicals, in this case, the square root symbol, and you will apply it to both sides. And you'll learn about something called the plus or minus sign, and why you need to put that in there. Now, x squared and the square root are kind of like inverse operations. They kind of cancel each other out. That will give us x equals plus or minus 3. So there will be some quadratic equations where you can simply use radicals to solve the equation. This will be one technique you learn, how you can use radicals to solve certain types of equations. Let's look at the second equation, 2y squared minus 3y equals 0. In this case, you're going to use a different approach. The radical approach won't quite work. In future lessons, you'll see why that doesn't work here. But it turns out you can factor the left-hand side. And the importance of factoring is, on the left-hand side, we have a product of two terms. Y is the first term, and 2y minus 3 is the second term. And if you have two numbers whose product is 0, that means one of those numbers has to be 0. So here, that means either y is 0 or 2y minus 3 equals 0. That's the reason you factor, is because when you have a product that's 0, you know that one of those has to be 0. Well, y equals 0 is one solution, and if you solve this second one, you get y equals 3/2. And that's one of the reasons you factor, is because if you have a product of some numbers and you get 0, you know that one of the numbers has to be 0. So another technique you'll learn a lot about is how you can use factoring to solve equations. Let's look at the third equation. This looks a little more complicated than the first one and the second because this has three terms, z squared, 4z, and 3. Well, it turns out in this case you can actually factor this as well, as z plus 1 times z plus 3. Don't worry if you don't see how I did this. This is one of the things you're going to learn when you learn about factoring and how you can use factoring to solve equations. Once again, we have a product of two terms. The first term is z plus 1, and the second term is z plus 3. Well, if their product is 0, one of them has to be 0. So we get z plus 1 equals 0, or z plus 3 equals 0. You solve both of these, and you get z equals -1, or z equals -3. So the technique here, factoring, is the same technique that we use to solve the second equation. And let's look at the fourth equation. X squared minus 2x minus 5 equals 0. For this one, just using radicals won't work. Factoring, I'm reluctant to say factoring won't work. You can always factor, it's just that there's no easy way to factor, is what I should say. Is it's not practical. That might be a better way to put it, is that factoring is not practical here, because you wouldn't be able to factor this using integers or fractions. You'd have to really go crazy. Instead, what you're going to do is you're going to learn how to use something called the quadratic formula. This is a formula that's guaranteed to give you the solutions to every single quadratic equation. Sometimes equations are simple enough that you can just simply use radicals or maybe do a quick factoring, but when in doubt, you can always use the quadratic formula. And by learning how to work with radicals and how to factor, you'll learn where the quadratic formula came from. Now you have these letters, A, B, and C. It's like, what do those refer to? These just refer to different parts of the quadratic equation. A is the number in front of x squared, 1. B is the number in front of x, which is negative 2. And c is just the constant term, negative 5. So to find the two answers, you're going to just plug these three numbers into the formula and simplify it. So here, the opposite of b is positive 2. Square root of b squared is positive 4. If you square negative 2, you get positive 4. Minus 4 times a times c is minus 4 times 1 times negative 5. All of this over 2. And you'll go through and learn how to simplify expressions like these to get it into a very nice compact form. And this, if you multiply and simplify everything under the radical sign, you'll get the square root of 24. All this over 2. Now you may wonder, is there any way to simplify this? There is, and you will learn how to do that. You will get 1 plus or minus the square root of 6. And that plus or minus symbol is another thing you'll learn about. What that means is you do this calculation once with a plus sign, and you do it a second time with a minus sign. And that will give you the two answers to the quadratic equation. Remember, the degree tells you how many solutions there should be. The degree is 2, there should be 2 answers. These are the 3 techniques you will learn to help you solve quadratic equations. You'll learn how to use radicals, you'll learn how to do factoring, and then you'll learn how to use the quadratic formula.